Okay, so we're just gonna do a simple example on a hyperbola. Yeah, based on just everything we spoke about in the in the previous lesson. So the first question is write down the vertical asymptote. First thing that you need to check here is, okay, you're given your hyperbola in this format. What is the value of a? Your value of a, is it positive or negative? So quick thing, your value of a is positive. You'd expect that when you draw your graph, say this is a asymptote, your graph appears to be something like this, right? Because your value of a is positive in this case. So that's just one quick thing that I wanted us to look at before we can actually start answering all of these questions. Now we can start answering these questions. First question, write down the vertical asymptote. So one thing that I've stressed is vertical asymptote is based on the x value. That is just where the graph is undefined. Now graph is undefined when this part becomes 0. So when x minus 2 is 0, our graph is undefined. So that means our asymptote is just when x is equal to 2. That's just it for your vertical asymptote. Now horizontal asymptote, we said just simple. Y is equal to q. In this case, the value of q is 1. So y is just equal to 1. That just answers the question real quick. Okay. Now going down, find the x-intercept of f. Now finding the x-intercept has never changed. It will always be the same throughout. Just the way you did from I think grade 8 or 9. Yeah. So let's just find the x-intercept. I'm sorry if I said y, but yeah, it's just your x-intercept. If you want to find your x-intercept, this is what you do for x-intercept. So this is where I actually start every single time. I mentioned that for x-intercept, I know for sure that on the x-axis, y is equal to 0. Now, take down my graph as it is. So remember my graph is f of x is equal to, oh sorry, why am I writing x? 3 over x minus 2 plus 1. So I said y is 0 in this case. That means this part becomes 0. 3 x minus 2 plus 1. Take 1 to the other side. So this is just your algebra. Minus 1 is equal to 3 over x minus 2. To continue this, you can multiply both sides by your lowest common denominator, which is just x minus 2. So this becomes, if you multiply there, this is just minus x plus 2 is equal to 3. This definitely cancels with that out. Take your 2 to the other side. So it means minus x is just equal to 3 minus 2, which is 3 minus 2 is just 1. Dividing by negative, this is just minus 1. So it means your x-intercept is minus 1. If you're asked to write down to get the coordinate of the y-intercept, of the x-intercept, you're going to write it as minus x 1, which you've already mentioned that y is 0. So that's just it. If you ask for the coordinate, and that is just perfect. Continuing with our graph, if you want the y-intercept of f, same way for y-intercept, I'm going to have my x being equal to 0. So that means here you are looking for f of 0, which is equal to 3 over x becomes 0 plus 1. That's just it. And what does that become? That is just going to be, you can punch this in your calculator. Simple as it is, this just becomes minus 1 over 2. So that represents your y-intercept. Next up, write down the range of f. Now, range, you said it concerns y values. So first thing you write here is y is an element of real numbers. Now, y is not equal to something. You said you just take down your y asymptote as it is. You see, y is equal to 1. Here, say y is not equal to 1. You are done with finding the range. Finding your domain for a hyperbola, x is an element of reals. Again, x is, go back, check. We said x minus 2, x is equal to 2, right? Here we're just going to say that x is not equal to 2. That's all because our graph is not defined when x is equal to 2. So that's just it in terms of the domain in the range. Now let's try find the axis of symmetry with a positive gradient. So first thing first, we said you can just make a coordinate of these two values, 1 and 2. So here it's going to be 2 and 1, because this represents the x and just that. That's your P and Q. If you want one with a positive gradient, y is equal to x plus c. That's where you start every single time. There's usually a mark allocated for having a positive gradient there in your in your exams. So there's usually that. Take note of that. Now you can substitute your 2 and 1 to find your actual equation, or you're finding the value of c. So this is going to be your y is 1, this is 2 plus c. That's just it. Take this to the other side. 1 minus 2 is just minus 1 is equal to c. So that means y is equal to x minus 1, because c is minus 1. With a negative gradient, again, you start with y is equal to minus x plus c. Sub in that again. This is going to be 1 is equal to minus, but this is 2 here, plus c, right? Minus 2 or negative 2, when you take it to the other side, what happens is here it's going to be positive, right? So it's just going to be 1 plus 2, which is 3. So c is equal to 3. That means y is equal to minus x plus 3, because, oh, why have I written c? 3, because that's what we were just looking for. So that's when you're looking for a negative gradient, an axisymmetry that has a negative gradient. Now finally, sketching the graph, right? Let's sketch the graph. First thing that you want to is put down your y-axis and your x-axis, right? Then from there you can start putting down your asymptotes. We said our first asymptote, if you go back, if you come back up here, x is equal to 2, you go to your graph, say x is equal to 2 here, so your asymptote is going to be like this. We use dotted lines to represent your asymptotes. We said the other asymptote is y equal to 1. So the first one was x equal to 2, y equals 1. So say y is equal to 1 somewhere here. This is going to be your asymptote. Perfect. So these are your two asymptotes. Definitely my stuff are not drawn to scale and they are not as neat, right? Please do make sure that your stuff are neat. Yeah. Let's talk about the intercept now. X-intercept, we found that it's equal to -1. So -1 is just somewhere here. Put that. And we found that our y-intercept was -half, right? Let's say -half is somewhere here. Now you just need to draw your graph. Should approach but never touch. There it is. There we go. So you definitely have your first graph up there. Next thing that you want to do is just draw a reflection of this graph on the other side. Remember, we said it should look like this, right? So let's draw the reflection of this graph up here. There we go. Perfect. Our graph is drawn. If you've got any question, look at this up again. Sure.